we've looked at integrals of the form with sines and cosines. Now we're going to look at the ones with secants and tangents. So I have the integral of secant to the nth power of x tangent to the nth power of x dx. And I'm going to go over the guidelines. So if the power for secant is even, remember before we said they always had to be positive, save one secant squared factor and convert the rest to tangents. And we're going to use secant squared is 1 plus tangent squared x. So secant squared x equals 1 plus tangent squared x, or tangent squared x is secant squared x minus 1. So if I have secant, it's even, so to the 2k, x tangent to whatever power, okay, this is even, so I'm going to keep out one of them, so I'm going to have secant squared to the k minus 1 times tangent times the secant squared that I took out, dx. So I'm going to convert secant squared to 1 plus tangent squared x, and this is going to be my du. So I'm going to have the integral of 1 plus tangent squared x to the k minus 1, which will need to expand, times tangent to the nth power of x times secant squared x dx. And again, that's our du power. Now what if my tangent power is odd and positive? I'm going to save, remember the derivative of tangent, secant tangent, so I need to save a secant x tangent x factor. I'm going to convert the rest to, and the rest are going to go to secant squared. So if I have integral of secant to the mth power of x tangent to the 2k plus 1x dx, remember this number is odd. So I'm going to take 1 for my secant, so I'm going to have secant to m minus 1x, tangent squared to the k power, and then I have that secant I took out, the tangent I took out, dx. This is for my du. Okay, this I'm going to replace with secant squared x minus 1, so I'm going to end up with secant m minus 1 power of x times secant squared x minus 1 to the kth power, secant x tangent x dx. And I would expand this and multiply through, and then I can integrate it. If I have no secant factors, and tangent power is even, and again positive, convert a tangent squared to a secant squared and expand and repeat if I need to. So I have the integral of tangent to the nth x dx. It's going to equal the integral of tangent to the n minus 2 of x times tangent squared x dx. I'm going to make this as secant squared x minus 1, and I'm going to have the integral of tan the n minus 2 of x times secant squared x minus 1 dx. And if I have tangents left that I can't integrate, then I'm going to do that again with some more values of tangent. If I have an integral that looks like this, secant to the mth power of x dx, if m is odd and positive, then I'm just going to use integration by parts. And finally, if none of above works, try converting to sine and cosine.